Hello, my name is Dmytro Chaplynskyi, and today I would like to introduce a new corpus of Ukrainian language called UberText, or more precisely UberText 2.0. UberText is a corpus of modern Ukrainian language collected from open source, and it's quite a big one, and it can suit different needs. It can be used by computational linguists, it can be used by researchers, it can be used by journalists. And this brings us naturally to the idea of the contract. Like, what is the contract in this meaning? Contract is the number of promises which product gives you. In our case, we would like to make this contract explicit. First of all, we are building a massive open source available for commercial use corpus of modern Ukrainian language, which is collected from different sources across the web. We promise that we will be updating this corpus quite often, like annually or biannually, but also we will have a rich number of metadata associated with these texts, but also tokenized version of the same corpus and lemmatized version of the same corpus, and even the lemma frequency dictionaries, which can show which word in Ukrainian language is being used the most among different part of speech texts. And this, by the way, is a great example of the concept. When you collect something once, you store it in a format which allows for the transformation, and then you can reuse it for different auditors, for different customers, for different needs. Like, we collecting the text for the computational linguists so they can train large language models and word embeddings and plenty of other uses, but also we share the same text, so they can be available for the linguists, for the philologists, for the writers, for the translators, for the journalists, and then can benefit from the same texts too. And this is basically the concept which lies in the core of the UberText 2.0. What do I mean? The text that we are collecting, it has metadata, as I said, and it is stored pretty much in the form that we've collected them from the web pages. Of course, for each web page, for each source, we have a separate spider which is tailored to that particular page. And this spider removes all the boilerplate, so we don't have all the menus and all that related text. It removes advertisement or call to action text like subscribe to our Telegram or Instagram. It just focuses solely on texts and metadata, and texts are stored in the markdown format. So we're converting the HTML page, the part of the HTML page we're interested in, into the markdown format, which is human readable and which has still kind of a structure of the page. So it has headers, it has text in bold, it has text in italic, and once these texts are stored, we can process them and gradually create layers on top of this text. So, for example, current size of the corpus is roughly 32, maybe 35 gigabytes when cleansed, and it takes quite a lot of time to tokenize it all. We have a nice tokenizer which was brought to us by the very friendly project called UNLP UK, which is pinpointing the problem of the tokenization of Ukrainian text. It does cleansing, it does the segmentation to the sentences, it does tokenization, and it does lemmatization. And to process this massive amount of text through this pipeline of the changes, it will take some decent amount of time, like maybe a couple of weeks. So on top of the text that was collected and which is sitting in our database, we are creating layers. So we have a layer of tokenized text, a layer of text just segmented to the sentences, a layer of lemmatized text, a layer of analyzed text. For example, UD part of speech tag, UD features, and other important things. And then that will allow us to collect once, to process once, and then generate different views on the very same data. Like we can filter by metadata, we can take not the original text, but the processed ones, and for example, calculate the frequency of the lemmas. And for example, we can even mine corpus in this manner, so we can take the text from this year and we can take the text from the previous year and calculate the frequency of the lemmas and then compare the distribution and see which words appeared in the lexicon recently and which became less frequently used. So this is just one example of how this architecture collect once, process once, and reuse in many different tasks can work. Now we can talk a little bit about the statistics of that corpus. It contains 5 subcorpora: news, fiction, Wikipedia, court, and social. Let me talk through every of them. News is the biggest one. It has like 38 news sources manually scraped from the major Ukrainian news websites, and it covers 23 years of Ukrainian news, and includes also like long reads, interviews, publicistics, and it contains roughly 7.2 million of text and pretty much 2 billion of tokens. Fiction is a little bit smaller. It takes the text which are publicly available through 2 of Ukrainian online libraries of fiction text, and it has a little bit of the poetry and 23,000 of text, but those are very long. The court is an interesting one because it has decisions of the Supreme Court of Ukraine, which is known to be quite high quality texts, and they do not repeat themselves pretty much, as many of Ukrainian court decisions do. And it also spans like 15 years or something. Social is the Telegram channels, like 264 different Telegram channels active through the last 2 or 3 years. Pretty much it's either the bloggers or the communication which is being done by Ukrainian state officials. For example, the Telegram channel of the president of Ukraine is a good example. And last but not least, it's a Wikipedia. So Wikipedia is still a huge source of information, and it grows at like it adds 10% of the texts year to year, and it has 2.5 or 2.6 million of texts. It all being collected with the help of the Scrapy framework, which is awesome framework for the site scraping written in Python. And each and every source has a separate spider written precisely for this source to account for all the specialities of this source. Then, when texts are collected, they are being stored in the Mongo database simply because Mongo allows for the good compression of the text. It allows you to have different subsets of fields for different documents, and this is important. On top of that, we have a separate collections of layers, which I mentioned, and we have a Django application which sits on this data and which allows us to launch tasks either manually, ad hoc based, or scheduled. So for example, if we got new texts, we'll launch that task which will process this text, which will clean them, segment them into the sentences, tokenize them, lemmatize them, and analyze them. And all this data will be stored in the respectful layers. And then we can export that, and we can export in different formats. Again, we can export basically different layers with different post-processing. And for example, we can drop the very short text, which happens, and we can drop the text which are identified as non-Ukrainians. Current version of the corpus has around 11 million texts unfiltered, which is roughly 3.2 billion of tokens. And after the filtering being applied, it translates to 8.5 and 8.6 million of texts and 2.5 billion of tokens, which is roughly 30 gigabytes of clean, uncompressed text. And of course, we started to use these texts almost immediately through the collaborations with different scientists and scholars. Some of them will be presented to you today in the same section. We will talk a little bit about how we use this data from the developer's preview of the Corpus to train fast texts for Ukrainian language, to train GPT-2 and to perform the instructions tuning for them, and also to work on word sense disambiguation. And it is nice because each of these projects has different angle, different point of view on this data, different use case. So we train, we mine, we compare, and in addition to that, we also released a bunch of models which are not covered today. So you can already see for yourself that the availability of the data can spur a lot of very nice and very different projects. And when you open source the data, when you release it, you can fool the research for many years, and I hope that in the next years, next conferences, we will see more of this data in use and more fascinating projects and more nice and clever results. And it's kind of, still fun to me, because this project is pure data engineering and software building. It's less of the research, it's just gets pieces together and creates a solution that can be used to release the new version of Corpus every year. And still so many implications and applications.